Thank you for your kind invitation. Good morning, ladies and gentlemen. We heard a lot of innovation from Herrn Knecht. It's hard to compete with a presentation after this. However, being a design consultant for 10 years, we learned that lots of things in tunneling, let's say, are driven by the stomach. This brought us to the idea to set up an innovation center in the middle of Austria between the universities of Graz, Vienna and Leoben. So we call it Technical University Austria, where we would like to go into the details. Why do we design this and that? What's the reason? How can we calculate it in a better way? So what we are setting up is a research and development center, a seminar center also for colleagues who are already in the business to be trained up. What we see, at least in our region, is we have a little bit of lack of manpower in different fields of tunneling, not only the engineers, but also people working at the face. What else we are completely missing is we have to train up our, let's say, emergency colleagues, because what we are doing right now is we are doing fire tests in all our tunnels with a fire load of about 3 megawatt. If you have a real fire in a tunnel, you have about 20, 26. If you have lorries in, can go up to 100 megawatt. There was a request from the Channel Tunnel between France and Great Britain. They asked us, could we do a fire test with 150 megawatt with lorries and so on in? So we were looking for an area where we are allowed to do that. It is an open pit mine, which is still very active. I mean, compared to South America, we are not having really much mining. But this is the most modern open pit mining in Europe, what is existing right now for iron ore, I have to say. 220 people are working there, and we were looking for a center where we have big machines, where we have very good trained miners already available. And we were looking for an area where we don't disturb each other. So we are in a separated area of this mine. The mining is there, the tunneling is on the other side. This mine exists, by the way, for 1,300 years. So there is quite a bit experience existing there. And lots of tunnels are existing there. Talking with the fire brigades, with the emergency colleagues, they asked us, please, couldn't you realize a big scale tunnel, so like what we have in situ, real double tube tunnel system for railway, a double tube system for motorways. Yesterday the colleagues who were present, we learned already that Europe has to fulfill that we have no bidirectional traffic anymore from 2019 on in high traffic tunnels. So they asked us, please do tunnels with double tubes, minimum length of 300 meters for motorways, but also for railways. And we were looking for, can we realize that? Asking, of course, the government, can you do that as a university building, so to say? And the decision was a clear yes. But it is also a training and service center for people who are doing maintenance afterwards in tunnels, because we are also missing a device like this one. So what is the situation actually? Actually, we get normally samples from any core drillings. We try to do our best with the normal laboratory tests, UniRCR tests, shear tests, all the tests which we need for static calculations for designing the tunnel. Yesterday we spoke about one step ahead, online chemical analysis for environmental friendly tunneling, and so is coming up. So this can be done in a laboratory, but it would be better if we could do all of that in a big scale in a real tunnel. So the layout, what we did for this test gallery is like you see here. We have tunnels which have a length of about 400 to 500 meters, are double tubes, get cross passages like in a real tunnel for the railway and also for the motorway. The red one is the motorway tunnel and the blue one is the railway tunnel. What we learned, by the way, is we did some tests with our students. and asked them, okay, you have an emergency now, what do you do? Because we saw some videos how people behave in case of an accident, real accident. And what we learned is, in case of a catastrophe, people react completely different and most time wrong. Maybe you heard of our big accident of our skiing tunnel on Kitzsteinhorn, where we had more than 130 dead people because they jumped out of the train and followed the smoke. Following the smoke is the wrong decision. But nobody was trained for that, and all of them died, and just 9 had the idea not following the smoke, go the other direction. And those were the ones who survived. And we said, couldn't we train that? And we had a big accident last year with a colleague from Netherlands with a bus in our Kleinalm tunnel. In the same situation. So the people followed the smoke. It was good luck, nobody died. So we would like to train the population. We would like to open this center also for the population to be trained. How do you react in case of an emergency? Learning from our students is, let's say, 90% do not know how to behave in a tunnel in case of an accident. And that's, if the students don't know that, we think also the normal population doesn't know that, so we would like to train or give the opportunity to the colleagues to be trained for emergency in this center. You have to think we get quite long tunnels, let's say this Brenner base, 57 kilometers. It could be that the train has to stop for any reason, and how do you as a passenger then behave? And this could be trained also in the railway tunnel. How can you get out of a train? How is it to open the cross passages? We learned from the Swiss accidents that people escaped to the cross passages, but were not able to open these cross passage doors. So they came quite far, but then they didn't know how to open it. It's a really pity not to know how these doors. And this we would like to avoid in future with such a center. Just some more detail. So for this reason, we will bring the full inner lining, how it is for a certain length on the left-hand side on the motorway tunnel, but also on the railway tunnel, so that you have the real feeling you are in a real tunnel, and what do you do then? The rest of the tunnels will be, let's say, single-line, because we would like to do fire tests there. We would like to do material development there, all kinds of research, which I will show a little bit later. So our big goal is to transfer the knowledge from the laboratory, which is, I would say, state of the art. How do we transfer this knowledge from the laboratory, what we normally got when I was a design consultant, to the big scale tunnel? Truly spoken, we do, all of you, I think, do numerical calculations. How sure are you that your numerical calculations fit the reality? Are there any material models for rocks available already which meet the reality? I already mentioned Moore Coulomb, Hook Brown, for London clay, Chem clay, whatever. But do these material laws meet the reality? We are far away from mechanical engineering, and we have to make a lot of research on that regard to meet the reality much more. Following Rabcevich's idea, having thousands of measurement results once available, then we can start to calculate tunnels. What we do before is rough estimations. I like to say 50% of that what comes out from a calculation is the truth. The rest has to be found out on site by monitoring, geotechnical monitoring. And this is another point which has to be developed. I mean, what do? We mount some reflectors nowadays on the lining. And then we have some distances between these measurement cross sections, and what happens in between. All of it is a guess. So we would like to get better also on that field with this training center. Yeah, we will set up also a hall there. We have some frameworks for building segmental lining elements. Nowadays we get the segmental lining elements from the construction sites which are around of us, because they are pretty big construction sites, quite close to us, starting from tunnels which are already existing, because if we walk through these tunnels, as I mentioned, these mining areas 1,300 years old, we can learn how tunnel development was going. If you go into these tunnels, you see the first, they didn't use some support, then they used some wood, then they used some, the concrete came up, they built very thick concrete walls, and then sometime occurred that shotcrete was developed, then they used shotcrete, so we can follow a bit the history of tunneling in these underground structures. The cross sections what we built are, as I mentioned before, the real motorway tunnel cross sections is normally double-laned in Europe are built. The left-hand tunnel gets, because of ventilation, is also a research topic there, gets a ceiling in between. The problem with our colleagues from the ventilation calculations is the same than we have with the numerical calculation of tunnels in the rock mechanics. You can do good simulations on ventilation aspects, but we are not able to do that on a research basis in a real scale. So the ventilation guys are waiting for this infrastructure to find out if their one-dimensional, most time one-dimensional ventilation calculations are fitting the reality. On the right-hand side, we will not put in this inner lining because, as I mentioned, we will do the material tests. Yesterday we had a discussion, is shotcrete watertight? Can we get it watertight? What are the mixtures to get it? So this is the facility where we will train also that. On the left-hand side, I mentioned already, everything will be built in like in a real tunnel. Same for the railway tunnels. The railway tunnels, we are building 3 main projects right now, the Brenner-Bess, the Semmering, and the Coram tunnel, all of them more than 20 kilometers long. This is the typical cross-section for that. Left-hand side railway tunnel will get an inner lining and all the equipment, including the tracks, so that we have a real railway tunnel in there. Right-hand side will get no inner lining to do the same trainings, fire tests in this tunnel. Yeah, we started already. The point is, what we are missing on the universities is a practical training for our students. The university courses got very theoretical. And there was a guy 170 years before of us who was the founder of the university, and he said, we are working in a practical field. So we have to train our miners, at that time it was mining engineering, in the mine, and he found these Eisenerz already, and he said, we set up the universities there because our lessons have to be half-time practical work and half-time theoretical. Anytime we lost all this practical work, and now it's completely theoretical. So our students get a master degree. Could happen that they get a site manager, but never did the job themselves before. We would like to change this situation. So one part of our master course is for example, surveying. So how to get the portal situation in situ, not just on a design drawing, but how do you get these portals there? And it's done by students. So all of that work, preparation, and also the construction site management is done by the students, supervised by us and supervised by companies. And the construction site manager of this tunnel site, to get the slope without sliding down, was a student of mine, which will graduate the next semester. And she did it quite well. I mean, the surveying didn't fit on the millimeter. In this project, this is not necessary. But to train the team, the students, how to do all these things, not just on a paperwork, but in reality, is, in our opinion, quite good training. You see here the slope development and then the tunnels. And the tunnels had to be placed on the right place, and everything is done by students. That's what we like on that. But as you see, supervised by, in this case, Austrian company, which is called Stettin. Just a few from the helicopter. Where are we? You see the two portal locations quite in the middle of this mountain. We are passing through the highest point of the mountain and come out on the other side. This is what it looked like, let's say, half a year ago. So we are now enlarging this area where we can pass into the tunnel. She was the construction site manager, and that's what I want to focus on. It's a student's lab, so to say, a student's education center. And you see, it's a woman, and the woman was the construction site manager, and the students were the workers. And I also brought, I think, just a small slide of some of them. Of course, it's a big team of the students, who are then the miners. Yeah, we do everything what has to be done. We are setting inclinometers, so we are training our students in the courses how to set down an inclinometer, for example. But theory and practical work is a difference. And here we are just drilling down this inclinometer, how to learn inclinometer is necessary in case of slope observation, how to bring down this inclinometer, how to operate it, how to measure then these things. Yeah, and it went quite quick that this was then known internationally, and we had last year already a course on surveying technology, how to survey tunnels and how to do geotechnical monitoring. This is a course coming from China, and what we did is we trained them in monitoring, how to operate a theodolite. I mean, it's not an innovation, it's pure basic knowledge. But if you didn't do that in your master course on a real tunnel site, it gets hard. And what we see is the construction companies, they don't have the time to train the young colleagues on all of these fields. And that's why they liked to come. Then we set up the first training course for tunneling, a real tunnel training course in India, in Mumbai. So we are now, I just was in India for 1 week. We started to do the theory there. And now the colleagues are coming to the research center and do all that what we did 1 week in India, now in this research center. Basic calculations, and now, okay, how to really tunnel. And then we have an NATM course, is standing for New Austrian Tunneling Method, and we do that on next Monday, 11th of September, we start the next course. We normally take 15 colleagues, but the request was quite high, so it was 24 in the last course. And we train these NATM colleagues who are coming in that last course, 24 students from 80 different nations on this research center. Theory first and practical work afterwards. And you see, all of them are a bit laughing. So my feeling is young people like to work and like to be trained in practical things in tunneling, not just in theoretic things. And we have also some, as you see, colleagues from South America. One was from Peru, the other is from Chile, there's another one from Brazil. However, I just took some photos with me. Yeah, the question is, what are the fields which we are studying there from the research point of view? I don't want to run through all of them, but just to mention geophysics. Geophysics, I learned, was not developed for tunneling. Geophysics was developed for the mining and petroleum engineering fields. They wanted to find the big blocks of iron ore for square kilometers. They wanted to find the oil bodies, but never, I understood the colleagues, we are building such a small tunnel in such a big rock mass, and we want to know where is the fault zone in front of this small tunnel. And what I learned up to now is these technologies are not prepared from the basics for finding a fault zone in front of the face. There has to be a lot of research to be done to get really clear results on that regard. Geothermal energy is a topic. We're just running a EU project on that topic now, because energy is a major topic in Europe. How to drill faster and deeper. The oil engineers in, our university has a petroleum engineering field. They are used to go down for 6,000 meters, but they would like to do that faster and with less, let's say, abrasion on their tools. And then, of course, concrete technology. Then we go to aerodynamics. And all this equipment which is in the tunnels is changing pretty fast. And we have to, let's say, develop this equipment which comes into the tunnel and have to find, let's say, verification methods to say this is the right equipment, yes or no. And it goes down to security research, fire tests, as I mentioned before. In parallel, we set up some, let's say, laboratory tests, but bigger scale in between. So we have a laboratory where we train the students on normal tests like we are very used to. But then we have to find a middle part, which is, for example, this laboratory device to test the segmental linings. Because up to now, we were not able to say, is the segmental lining taking this moment and taking this normal force? Can we replace the steel which is in these segmental lining by fibers? Can we do that by steel fibers? Can we do that by other fibers? We are doing tests on that. It's just a single element test. It doesn't say that the full ring is then really working. Because the backfilling is very essential, and we have to find out that in another place, what we do then outside in the research center. Here, or in the laboratory, in this big scale test, we can find out what is the safety limit to the carrier, what load can we take in the moment and normal forces terms, but not on the full ring. So these are tests done in this second laboratory. And then we brought up some segmental linings to the research center already, where we will start right now to test the backfilling of these segmental linings. There are different possibilities how to backfill, and we are not sure. I will say we have a list of at least 20 questions open for the backfilling. Is the backfilling working also in 10 years? Yesterday we were speaking about sustainability. If the trains are running with, let's say, 250 kilometers, we fill it back with peak gravel, and every train brings a vibration into the tunnel. Do we then know exactly after 10 years the tunnel is still stable? So we are working on backfilling strategies, but also on monitoring of the full ring to get out the deformation of the rings and the load in the rings. In parallel, we have a seminar center there, so what is trained outside can then be talked with the groups on this research center to be discussed the results. What we learned is also that the military has quite a lot of questions for underground things, and this is just a delegation of the Austrian military forces to have a look at it and to fix what are the trainings to be done in this underground center. Yeah, for us it's quite unique. We are completely independent, as we are a university building. We are an independent body. We are not paid by any company. We didn't want that. We said we will start that if the government gives okay for the finance. So it's completely independent. We are trying to do scientific work there, applied research with a real environment, practical relevance, and we would like to do know-how transfer from the theory to the practical world. This is the big goal. Just to show where it is, on the picture down there, you see this is the map of Austria. Yesterday, the taxi driver explained how many people are living in Argentina, so we are pretty small. In the place where this research center is, we have 4,000 inhabitants, so it's a pretty small village. However, it's placed in Eisenerz, it's Styria, it's in the middle of Austria, it's in between the three universities which I mentioned before. Yeah, what we hope is that we can exchange at least the researchers. We had just a talk with Bolivia, Rodriguez before. Maybe we can bring some colleagues from South America to this research center. The problem is a university, there are so many universities, we hope to attract researchers to come to such a facility to really train on a real scale, to attract research in this field. Of course, also academically educated personnel in the area of underground mining and tunneling. We hope to attract it for students. The problem is, I don't know the South American situation, but technical studies in Europe are going down. Everybody in Europe, I would say, would like to get a lawyer, a medical doctor, or something doing in the economics, but very few are interested in the technical field. So we would like to see more students on the technical field, also more international students, like it was before, when, for example, Rodriguez was in Austria as a Bolivian colleague. We would like to train the service and maintenance staff. Of course, we would like to cooperate with companies if there's a good basis for. User, as I mentioned already, for the road and rail infrastructure, and also customers for the industry. The organization is a completely, I would say, a simple one. It's university-based. There's no company behind. So it's like working with a university. This is an assumption because it's not a laboratory building, but it's tunnels which are to be used for the research. This is how we think we ensure the independent research which can be done there. Yeah, this is the situation, how it looks like. We are right now building these tunnels with the students further and companies, and we welcome you to a fruitful cooperation. Thanks for your attention, and I'm open for questions.